This is a video. I was about to say a movie. Oh, God, no. This is a movie about a video about sculpting. Oh, I'm losing it. Uh, Now, sculpting with multiple dead issues. I've made another video on this, maybe two, I think. Yeah, one was on how to resolve some circular references associated with all of this business. All right, let me, I'm going to try to explain this in the context of a much more realistic case this time with construction periods and changing cash flows and taxes and interest income and DSRAs and everything else. Okay. The uh, first point I want to make about sculpting is that I was so wrong about this and I was corrected by Hetty. You know, I used to almost define sculpting as maintaining a DSCR that's the same over time. So what I'm doing right now is I'm going all the way to the bottom and the back of the model, and at the very end we have a target, actual DSCR, which is the CFADS, cash flow available for debt service, divided by the debt service, and it meets our target. And to get the debt service, we have, the cash flow available for debt service, and the debt service, we have kind of a basic cash flow waterfall, which is our cash flow after the construction period. So I'm going backwards. Now, I just said, well, okay, the DSCR is constant if you have sculpting. That's not really, really true. It can change. It can be a more complicated where we have to use some interpolate functions. And I'm going to get to that in the second part of my video. And I hope I didn't wake anybody up. Okay, now remember, I don't know if you remember, if you probably didn't watch the last video, so this is probably irrelevant. If you have a funding section of a model, and in our funding section, we have these things that will cause circular references when we hit this wall. That's the interest during construction, the fees, and the DSRA account, which note I've still left out. Okay, now if you go down to the to the cash flows section, these kind of things in between the EBITDA, that's like our CapEx, and CFADS, that's like our total funding needs. These things down here, they are the nightmares that can cause circular references in the sculpting. Because if we change the debt, the interest expense changes, and then the interest expense changes, then the taxes change. And if we change the DSRA because we change the debt, the interest income can change. And same with the DSRA account. Okay, so if we do include that in the CFADS, which is another issue altogether. Okay, right now I put it down here. Where to put these changes in the DSRA is a whole nother subject. Okay, now if you going backwards, well, we need to have a profit and loss statement and get the taxes for that section of the statement, and then I want to kind of show you the result. Now why don't we do this? We have all of these debt issues, and I'm going to make a little graph, and I hope you remember. Let's make this graph only over the operating period, or maybe only over the key period, which is the we'll get back to a little bit later, but it's the repayment period for this maximum debt issue, and that's this little true and false statement in line 386. Now, what I should really be doing is making some sort of exercise for you, and I think perhaps I'll Add that later. So I'm going to make this graph. Now I don't want to graph all this crap here, and I don't want to graph all this crap that's zero at the end. I only want to graph the different debt issues and show you kind of what's happening. And I'll put an if statement, and we'll go up to the this one, right? And if it's true, then we'll put the date in, and otherwise we'll put an NA and open and close bracket, and I think Shift Control R, and then we have our thing and our x-axis, Shift Control 3. Whoops. So I am doing a little bit. Shift Control 3 to get our dates formatted, and then let's graph our total debt service with, I'll just press F11 to make a graph, and let's make it a, change the chart type, and let's make it an area chart and stack it. And this is what I want to show you, and this is what we're really aiming for. And we're aiming to also be able to change the DSCR and see what happens, but essentially all the different debt issues are sculpted, and the total amount, as I stacked it, is married against or varies according to the cash flow. Is this maybe you're silly enough to think this is art? I am almost, because it was so hard to do. Okay, and this last one I'll call the capture debt issue, and this is low over here because we have all these other issues that are taking up our kind of CFADS capacity, if you want to call it that. And then by the end, we use all the CFADS to repay this last issue. Actually, this is the total debt service, but it illustrates what we're trying to do. And we're trying to make sure that these different issues, all of these debt issues, have the same sort of pattern. And so over here, they all have the same repayment profile. And then when this one finishes, all these two have the same repayment profile. But the last one captures the rest of it to make sure the DSCR is the same over the life. I think I probably repeated myself about 5 times there, and I apologize for that. Now, in order to do this, I cheated. I cheated just like I did with the funding. I said, for now, let's just make the CFADS equal the EBITDA, so we don't have this circular problem associated with taxes, with potentially interest income, and maybe even with DSRA changes. And there can be also a issue with fees if if the DSRA account has a letter of credit rather than a balance, which seems to be happening more and more. Okay, now, so here I added this in a whole separate section. I'm not sure if I put it exactly in the right place. I put it just below our debt balances for all the different debt issues. Okay, I'm sure this has not ever been. I've never seen this in an actual model, and I don't know what to say. Okay, maybe one day I'll see it. Now, here is the technique. I will try to explain the logic, a little bit of this, a little bit of the logic, but in order to get our sculpting to work, we kind of first need to know what the total aggregate sculpting for all the issues is. Now, the problem with that is we need to have an interest rate, and we need to have a consistent interest rate. And the reason we need an interest rate, let me just start it. We have CFADS, which is again a cheated number. And then we have our target DSCR, which the good news was that was equal to our final DSCR. DSCR when we checked everything at the very end. And so our debt service is just this divided by this to get the debt service. I think I did that right. And then we could have changing interest rates, and I've emphasized for years now that why don't you, instead of using an NPV formula or mucking around with that, why don't you just create a little interest index and and multiply kind of that by either the debt repayment, because you might have a grace period, and this works totally fine with a grace period, excuse me. Suffering these days for some stupid reason. We just augment this, grow this, but we only grow it after the case. Now I used the debt IRR itself. Now there's a problem here because the debt IRR is, I'm going to show you, is computed as the debt service relative to the upfront payment. Now, when you need this, when you have this little index, you can just use the sum product and divide the debt service by this. That's like taking the NPV. Okay, I don't have to go through that again for the umpteenth time. Okay, and that's the total amount of the debt. And that total amount of the debt is the same as the total amount of debt that was way up here in the sources and uses of funds statement. And that total amount of debt gets divided between the 4 debt issues. Now, okay, so that's kind of step number 1. Get the aggregate debt issue. Now this is going to be a classic circular reference. It's almost too obvious because to get this IRR, we need all the debt service. But to get the debt service, we need this amount because we're going to use this amount to allocate amongst the different issues. Now, the next thing you do as you're going through issue by issue, something I didn't explain enough, is number 1, you have to figure out what's the issue with the longest tenor, because this issue that has the longest tenor is the capturing debt issue. This is the one that you use to kind of make everything work. Okay, I guess in this period we have a similar. Its sculpting does not look like the rest of the sculpting. Okay, all right, the rest of them are kind of okay, and this is the one that picks up all the rest. And if you don't like that, the way it's working, you'll have to change the relative amounts of the other debt. So if we have this one right now is 50%, so if this one's a lot more and this one's a lot more, you can pick up the rest of this. But in the very last periods, this is the only sculpted debt issue, so this is going to have more cash flow to sculpt than in the earlier periods. And again, that was a shitty explanation, but I'm going to keep going. Okay, now I'm going to start with these non-capturing debt issues, and I just did this by trial and error. Perhaps there's a better method, and I'd love you to tell me. You won't. Nobody ever tells me anything. But here's the way I did it. I said the first thing you do is you got to recognize that these other issues have different interest rates. So the NPV of the cash flow, it's exactly the same cash flow. The CFADS is exactly the same all the time. But the PV of this cash flow is different for different issues, because in this case I said it's 3%, this one it's 6%, this one it was 5.87%, and the capturing kind of last debt issue was 5.5%. Okay, so now what I did is I said, okay, let's take the Let's take the NPV with our whole trusty little sum product function. Let's take that NPV, and now the total amount of debt is our 10% that I discussed in the last video. If you didn't watch that, it's just taking each different debt issue, and we just said, okay, the first one is 55%, I think. Here it was. Okay, and the second one was 10%, and so forth, so on and so forth. Okay, now where am I? Okay, so this is the total amount of the issue. Now I'm going to compute one of these LLCRs as this divided by that. It's the PV of the cash flow over the debt tenor. And I should have also told you I need a little switch that goes through this short debt tenor. Okay, so this NPV of the cash flow associated with this debt depends on the interest rate and the debt tenor of the issue. And then it depends on the total debt issue. And then we divide one by the other. And you use this this number then to derive and it's a really high number, so there's a low debt service associated with it. But when you use this to compute it, it's just the basic formula that the NPV of the debt service equals the amount of the debt. And if we use the LLCR, the NPV of all of this computed debt service will be this number. Okay, and we'll have kind of sculpted it against those cash flows. Okay, and then we go to the next issue and do exactly the same. Now, notice that this issue, principally because we have a lower interest rate, it has a lower cash flow. If a lower NPV, which means we have a lower DSCR or LLCR that we're applying it against, and we get some higher debt service because of the lower interest rate. And the final one, it's got a little bit higher. Okay, and then we compare that to the total amount of debt, and then we get the debt service for these different issues. Those are the non-capturing debt issues. This is the LLCR method. I'm going to come back to that. It is possible that, these, again, I'm going back to the graph, but these things don't have to exactly match the cash flow. It might be possible that this goes up a little and this goes down a little, and it could be more complicated, but I doubt it, frankly. Okay, and then we finally put the capturing debt issue in. And to get the capturing debt issue, okay, we'll first put the total debt service. Now I go through this formula again and again and again, and maybe I'll do it here. When in project finance, I have, whoops, I didn't mean to go there. Advanced issues, or no, this is sculpting part 1, and this is about, no, is it this is sculpting with fees, sculpting with interest rates. You can see how it is. Sculpting with multiple debt issues or balloon payments. Okay, I don't think this is easy, but there is a basic formula that if you have debt service that's non-sculpted, or in this case, that's non-captured debt service, the DSCR is just the CFADS divided by both of them, and then the sculpted debt issue, CFADS divided by DSCR minus the other. Now, I went through this whole kind of theory and tried to explain it as best I could. And we have the captured debt issue somewhere down here. I don't know where I put it. Who cares? I'm getting back to the formula. Okay, back to our analysis. total debt service that we know we need to get our 1.35. Okay, well, DSCR. This was the aggregate thing I showed you at the beginning of the video. I'm sorry, this is a little bit tedious, and if you're just starting in project finance, you're going, OMG, I can't stand it. Whatever, you can say, OMG, you're a MF dot, whatever, you asshole, this is too complicated. I wanted something simple. I wanted something I could do, and I could learn in while I'm riding the metro in 10 minutes to see how sculpting works. Well, I've got a simple sculpting thing, but if you have multiple debt issues, I am sorry, switch off the goddamn video and watch a basic one. Really. Don't give me some comment that's going to make me depressed. Okay? That you take this net debt service, which is the total minus all the rest of it, which is all those non-captured debt issues below, which is just summing the debt issues service from all the way down there, and then you to do the NPV just like you did before. This is the this is the debt service on the captured issue. Okay, and then you take the here I took the sum, but there's the NPV of the debt issue, and here is the magical part of this. It's really just about magical, and that magical part is that when you do all of this, it all matches this number at the top. But the only way it matches this number is if you take this debt issue and this debt and all the rest of the debt, and you compute the debt, you compute the total debt service. Just a minute. Oh, here, that was in our little thing here. You compute the total debt service on all the issues. Now, when you do this, just a minute, you better put the total debt issued here, and you better put it in just one period ahead of this. And then you can compute a regular old IRR. This could be a semi-annual IRR, a quarterly IRR, a monthly IRR. Who cares? But you put all the debt service for all these other issues, you sum them all up, and then you contrast that with the initial debt that you had right at the beginning. So I just put a little true and a false for when this is the period before the COD, the famous, pre-COD period. And then we've got all this. Now let's do something. Let's pretend that the DSCR, instead of being 1.3, is and I'm going to show you now a classic kind of circular reference problem, because I told you I can't really compute it till the end, and we need that IRR on the debt in the very first place, and so you have a little bit of a problem. So up here, this is the driver. Let's make this 1.5. Now when I do that, the total debt should have gone down. That's it. It went down, and the equity went up. Now what happened here is I'm skipping all the way down, and I'm putting this file on the website, so when I skip up and down, you can try to work with it and try to struggle with it, and I get a different number. Now here's the problem. When I go down here, now the debt IRR, I needed a fixed, I should have told you this, I needed a fixed IRR to resolve the circular reference. Now, let's do this by hand. So here's what happens. This is our fixed amount. So you always copy from the computed and edit space, paste specialist value to the fixed. But our debt amount is this, and we need to also fix the debt amount. I should explain why, but I'm not right now. And then it all resolves. Now you could have made a little macro to do that. That's a copy and paste macro. And let me see. That seemed to have, no, it didn't. I just really screwed up. What an idiot. We copy and paste special as this to the other one. And then, oh no, I've got to copy and paste special as values this. And then I've got to copy and paste special as values this. Now, why don't we do our horrible, disgusting uh, copy paste? Okay, let's put a total difference here. Okay, and let's do this plus this, and let's do it right. I'll do it right for once. I'll put total diff. So I'm going to name this range. And we're going to do a copy and paste macro and keep going around and around until that total diff uh, goes down to 0. So we could call this, this would be the total debt from the sculpting. So this is computed COMP debt, and this is fixed debt, and let's name those two ranges. Okay, oops, let's do that again. Shift Control F3. We don't want the top, we just want the right. We better define that again. And this is computed IRR, and how about fixed IR? Okay, and let's select these. Now, when I'm sure I told you that was Shift Control F3. I'm sick of telling you that. Okay, and let's go around and around until this total difference equals 0. So we could press alternate and F8. Oops. And what am I doing wrong? Okay, and I don't know what I was doing there, and let's call it circular. How about, this is debt IRR circular. Okay, debt IRR circular. Okay, and I'm going to create just a brand new little old macro, and I'm going to try, here's how about this? This is just because, I am so old and I forget these things all the time. I am going to put these right here. Okay, and then I won't make quite as many errors as I would otherwise. And what we do is we go around and around, and we can you can do this 100 different ways, but you can do while range tot diff equals 0. Okay, not equal to 0. So we're going to go around and around, and then we, at the end, put loop. I believe that's right. I don't do this very often because I think it sucks so bad. And then we always assign, so we put range fixed debt, and it doesn't, the capital doesn't matter at all, equal range computed debt. Okay, and then we put range fixed. See, I would have forgotten this. Equal range computed IR. All right, I think that's okay. All right, and that's it. And then we think, oh man, am I super smart? I am so good. I do a copy and paste, and you really suck bad when you do that, because we're going to show you such a much better way to do this. It's not even comparable. Okay, and let's try this. And I'm sure I made a mistake, probably, but I'm going to put a little button on it and call it optimize and all this crap. Okay, and then I'm gonna click on this one. Okay. All right, button number 40. Now make sure and save the file first. Okay. Okay, and then it worked. Okay, the problem with that is now if you ever do a scenario or sensitivity, you've got to run this. If you're going to change it from P50 to P90, you have to run this. And this is just one tiny little thing. You've got to put so much of this stuff in these copy and paste macros, it's going to take forever. Okay, so I've got a way to kind of resolve all this stuff. All right, but that's not now. We can change the change all the excuse me, the DSCRs and see what happens to the excuse me, see what happens with sculpting, see what happens to excuse me, the IRI and so on and so forth. So that's basically the issue. Okay, I mean the method. Now, I'm not really quite finished because this assumes that the debt sizing is always going to be from the DSCR. But what happens, I'm up here, excuse me, what happens if the debt sizing is, if this DSCR produces a debt to capital that's above 80%, then we're going to be constrained by the 80%. And we've got to kind of do either or. Or what happens if you just want to fix the debt? You just want to fix the amount of the debt and then compute what the, excuse me, what the sculpting is. And I have a method to do that. It's not exactly necessarily always perfect, but it's a really, really great start. It's the LLCR method. And I'm going to, since I am at 33 minutes on this one, I'm going to stop on this one and address that next one in the next section.